So hello guys, my name is Rutvik and in this video we are going to talk about the central limit theorem, right? So first of all, let's talk about why we use central limit theorem. We use central limit theorem to convert. Suppose we have a population here and we need to check, and that population might follow the distribution, any type of distribution here, right? So in order to, and I want to convert that distribution into Gaussian distribution, right? So in order to do this, we need to use central limit theorem, right? So in this video, we are going to also talk about how we can convert and what is the process to convert a particular distribution to Gaussian distribution. Suppose if we have a population that follow the another type of distribution, because there are lots of type of distribution available, and we need to convert our population in such a way that for that whatever output we will get after the conversion of the population, that output will follow the Gaussian distribution, right? So the chart gonna like this. So I'm going to process some data here. So here is some process occur, and after the process whatever output we will get, that follow the Gaussian distribution. So this is the process, right? And this is all about the central limit theorem, and this is the answer of this question, that why we use central limit theorem in a data science, right? So the another question is that why we need to convert Gaussian distribution every time, why we check every time that particular data follow the Gaussian distribution or not, what is the reason? So in order to check all this reason about the Gaussian distribution, I've made a detailed video about the Gaussian distribution. You can check this video from the I button, right? Okay, so the first thing, suppose we have a population and I need to convert this population in such a way that the output will follow the Gaussian distribution, right? So I'm going to convert in the samples. Suppose I have a population and in which I have a 3000 of data points, 3000 data points I have in a population, and I'm going to create 100 samples from them, samples, and each sample contain probably 30 each sample contain 30 data points, right? And I'm going to take the mean of each sample and give a label x1. If the sample number is 1, then the mean of that sample is x1 bar, and if the sample number is 2, then I'm going to label them as a x bar 2, right? So this is a basic thing that we need to process our data for the to convert a population into sample, right? After that, whatever data, suppose I'm going to I'm going to calculate the mean for 100 samples, then the last mean would be x bar 100, right? So in this way we can calculate the mean. Now whatever mean I have, like suppose x1, x2 bar, x3 bar, up to x100 bar, I'm going to use these samples and plot the graph. And guess what? If I plot the graph on this data points, this 100 data points, which is a mean of the samples of the population, right? This is the means of the population of the samples, and that samples I've got from the population, right? Okay, so and that graph would be the follow and this particular samples, this particular means follow the Gaussian distribution. Gaussian distribution, right? So this is about the central limit theorem. And another thing is that suppose we have a distribution, suppose we have a population and that follows the Gaussian distribution, right? That follow the Gaussian distribution, and the mean is mu and sigma, this variance is sigma square. So if we use the same method, if we perform a central limit theorem on this population, then whatever data or whatever output we will get, and that follow the Gaussian distribution, but there is a little change in a parameter. So after performing central limit theorem on it, our output definitely that will follow the Gaussian distribution, but the output will change. The mean will be the same, whereas the sigma, the variance, will be divided by n. So now the question is, what is the n? The n means the number of means or number of samples that we created from the population. Number of samples that we created from the population, created from the population. So this is all about the central limit theorem, and also in this video I have discussed why we use central limit theorem, and where and how we can use central limit theorem, and what is the process to use central limit theorem, right? So thank you for watching.